Welcome to Unit 2, Lines in Triangle Relationships. This is the first video of Section 1, Intersecting Lines in Transversals, and will primarily deal with vocabulary. For the purpose of time, I have typed out the definitions and will talk through them instead of writing them since my penmanship is not very good. Okay, so let's start with our goals. First of all, after this lesson, we will be able to identify and apply properties of parallel lines, including properties of angles formed by a transversal, and then solve problems and logically justify the results. Our second one is to identify and apply properties of angles, including corresponding, exterior, interior, and same side interior, and then again solve problems and logically justify results. So very much the idea of getting some vocabulary, knowing the properties of those vocabulary, and then applying them to problems. All right, so let's start with our vocabulary with a transversal. A transversal is, a line which intersects two or more coplanar lines. Now, coplanar means they are on the same plane, and by plane we mean a flat surface. And if the piece of paper we're drawing on is a flat surface, that counts as a plane. So in other words, line R intersects two other lines. That means that line R is then the transversal, because the line R intersects line P and M. Okay, so it's very important to know the difference between the transversal and the other lines. Our second definition is corresponding angles. Now again, our point here is to draw a transversal and then create these angles 1, 2, 3, 4, 5, 6, 7, 8. So these angles are now created, and we're going to talk about how they are related and described. So corresponding angles are in the same position relative to the line in transversal. So if we say angle 2, which would be considered upper right hand corner of those two intersecting lines, in this intersection point, the angle that is in the same position based on the other one, upper right, would be angle 4. So angle 2 and angle 4. And now you see my handwriting on the smartboard. Not very good. Okay, so let's now talk about another vocabulary word, which is alternate interior angles. Now here's the definition. Angles on opposite sides of the transversal and inside the intersecting lines. So some key things here that we need to follow very closely are they are on opposite sides of the transversal, and that's here. So they are on opposite sides inside the intersecting lines. So that means they are in here somewhere. So a pair would be considered opposite and inside. So angle 2 is inside, but opposite sides of the transversal would make that 6. And we could also say 7 and 3. Another definition would be, clear that off, alternate exterior. Now notice the definition of this one. Now we're talking about opposite sides of the transversal, which is the same, opposite sides of the transversal, but now outside the intersecting lines. So now we're talking about here and here. So we have 1, 8, 4, 5. So to be opposite, we're talking about angle 1. Here's that, but it has to be opposite the transversal and outside, angle 5. And then we could also say 8 and 4. Another definition is same side interior. Same side interior has same side of transversal, that's different than the other two, and then inside the intersecting lines. So same side of the transversal, same side of the transversal, would be either this side or this side, but not alternating. And it's inside the intersecting lines, so it's in here somewhere. So same side would be, if I said angle 3, same side but interior would be angle 2. So angle 3 and 2. And we could also say angle 7 and 6. And we'll finish with a linear pair, which is a review of what we had last unit, angles that are adjacent and supplementary, and vertical angles that are opposite the vertex. So we would finish by saying two lines crossing, these are vertical angles, and a linear pair, supplementary and adjacent. And this ends the first video.